Lesson 19.4, Task 1, Sampling Distributions. Develop a distribution of sample means and sample proportions. The mean, proportion, and standard deviation of a sample are affected by the data collected and by the size of the sample. The table shows the identification numbers, grade levels, S for sophomore and J for junior, the scores of 40 students who took a standardized test at a school. You will need to work together as a class to answer some of the questions. All right, so you can see down through here, S means sophomore, J means junior, and there are 40 different scores. These kind of look like SAT scores, but I'm not sure what kind of scores. All right, so use technology to calculate the mean score and standard deviation for the population of the 40 students at the school who took the test. Round to the nearest hundredth if needed. Also find the proportion, P, of sophomores in the population. Round to the nearest thousandth if needed. All right, so to use technology to do this, we're going to use our calculator to enter these scores. So you're going to have to go back up, go ahead and grab your calculator. You should do this as practice because watching me do it, you may understand it, but you're going to remember it better if you do it yourself. So take the time to actually enter these numbers and go through this process. All right, so turn your calculator on and go to Stat. If you have something in your table, we're going to hit Enter because we're going to enter numbers in the table. If there's numbers in the table, you can do second plus 4. Second plus 4 will clear your list, and then you just go back in to edit again to enter the new list. All right. So go ahead and pause the video for a second and enter the list. I've already taken time to do that. But again, I think it's important that you enter these numbers. All you're going to do is enter the scores. So you're going to enter all the scores in L1, and then I'll show you how to calculate the mean standard deviation from those scores. All right, hopefully you've paused the video and you've entered all 40 scores in your list. So now we're going to go back down and answer the questions that it asks. All right, so it says find the mean and standard deviation. All right, so in a previous lesson, I told you that X with a bar over it is actually the mean in your calculator. So this is the mean symbol. But X with a line over top of it also represents mean, and that's what you're going to see in the calculator. This is standard deviation, and P in this case represents the proportion of sophomores in the population. All right, so once you have your list, you're going to click on Stat again, and this time we're going to click over to Calculate, just like when we were doing linear and quadratic regression and stuff, but this time we're not going to scroll down to find one of those. We're going to stay on one var stats. One var stats is going to give us a bunch of information. All right, so again, the X with the bar over it, this is your mean. Standard deviation of X here. And it also gives you several other things as well. It gives you your minimum, Q1, median, Q3, and your maximum value. So we may be looking at those a little bit later. Right now, we need the mean. X bar, remember, is the same as your mean. So 1105.75. It says round to the nearest thousandth if necessary. So 1105.75. All right, standard deviation is 205.096. And since we're rounding that to the nearest thousandth, we're going to round that to 205.10. Let's see if that works. 205. All right, and then the proportion of sophomores, we're going to get that by counting how many sophomores out of the 40 there are. So go back up here. So you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 out of 40. So do 17 divided by 40, and you get 0.425. So 0.425. All right, so that's how you would use your calculator in order to find your mean and standard deviation. All right, use a random number generator to choose a sample of 5 students, find the mean of the sample. Round to the nearest whole number, report your sample mean to your teacher. Create a histogram using the sample mean reported by members of your class. Calculate the mean of the sample and the standard deviation. All right, so I would practice doing this just so you can use your calculator to find the standard deviation and mean of another set of data. To find random number generator, if you have a phone, or you can use your calculator, just type in random number generator and you'll find one that's like a spin wheel. You can put however many numbers in it you want. There's other random number generators as well. So this is something that you should practice just to get used to using your calculator to work with data. All right, that's all for task 1. If you have any questions, let me know. Lesson 19.4, Task 2. Use the sampling distribution of a sample mean. A sampling distribution provides the data that describes the variance of a particular statistic over all samples of n individuals from the sample population. In Task 1, you approximated a sampling distribution. The mean of the sampling distribution of the sample mean is written as, you can see this is the mean of all your x's, and the standard deviation of the sampling distribution of the sample mean, also called the standard error of the mean, is written as, and this is the symbol for standard deviation of all your x's. All right, so properties of the sampling distribution of the sample mean. If a random sample of size n is selected from a population with mean and standard deviation, then the mean of x's equals your mean, and the standard deviation of your x's equals the standard deviation divided by the square root of n, where n is your sample size. The sampling distribution of the sample mean is normal if the population is normal. For all other populations, the sampling distribution of the mean approaches a normal distribution as n increases. All right, so remember in the previous lesson we talked about normal distribution. We looked at the normal distribution curve, how 68% of your data falls in 1 standard deviation, 95% falls in 2 standard deviations, and then 99.7 falls in 3 standard deviations. So that's kind of what that's relating to. All right, so it says the mean weight is 12.3 ounces and the standard deviation is 0.15 ounces for a box of healthy flakes. All right, so it says the weight in ounces of cereal boxes of a given size are normally distributed with the mean and standard deviation shown. For random samples of 25 boxes, what interval centered on the mean and the sampling distribution captures 95% of the sampling means? Write the given information. So n is the sample size because there's 25 boxes. This is your mean, so your mean is 12.3, and your standard deviation is 0.15. So it says find the mean of the sampling distribution of the sample mean and the standard error of the mean. All right, so the average or the mean is 12.3, so that's given. And then, so the standard deviation is going to be the standard deviation divided by the square root of n, and again, n is your sample size. All right, so we're going to have standard deviation, that's given, 0.15, and we're going to divide that by the square root of 25. Square root of 25 is 5. So we're really doing 0.15 divided by 5, and that gives you 0.03, or 3%. All right, so it says, what happens to the standard error of the mean as the sample size increases? Well, as the sample size gets bigger, the standard error would decrease. So the less samples you have, the more error there is possible, but the larger the sample size, that would decrease. All right, so in a normal distribution such as this, 95% of the data falls within 2 standard deviations of the mean. Okay, again, remember from normal distribution, 2 standard deviations is approximately 95% of the mean. All right, so to calculate that, we have the average, 12.3, and we're going to subtract 2 standard deviations. So 2 times the 0.03, and that's going to give us about 12.24. Okay, so that's 2 standard deviations to the left because this is minus. And then we're going to do the same thing with adding 2 standard deviations. So again, we take the mean, 12.3, and we add 2 standard deviations. All right, so 2 times the 0.03, and that gives us 12.36. All right, so 95% of the data should fall between the 12.24 and the 12.36. So the interval from 2.24 to 2.36 ounces captures 95% of the sample mean. What does this mean in terms of cereal boxes? All right, so this means about 95% of the sample. Means of sample of the 25 boxes are between 12.24 and 12.36 ounces. All right, that's all for task 2. If you have any questions, let me know.